Hello guys, welcome back. So today we are going to learn about recursion. We have already learned in previous chapters that a function can call another function. For example, if we have function hello, or I would say this is a function greet, and it can call like function greet is print hello world, and there is another function which says function ask. Then it is like we can call another function which is greet, and as well as we can continue our what do you need. We can add another statement as well. So there is no limit of how many functions we can call. So it's like so yeah, we can see like we were able to call function greet from ask function. Now there is no limit of how many functions we can call. So today we are going to learn about recursion. So what is recursion? Basically, recursion is that it's a programming technique. You will find this in every programming language where a function calls itself. So rather than calling, like here, if we have ask function and this is calling greet, so here ask function will call itself and it will solve like certain types of problems. So it is used to call, for example, factorial or any other kind of problem. So like we already know what is factorial. So factorial, if I have to represent, so for example, in a simple way, so if we want to find out factorial of 5, it is written like this in mathematics. And okay, Julia doesn't accept this. So factorial of 5 is 5, 4, 3, 2, 1 until it is 1. So answer is 120. So you can also go on Wikipedia and search about factorial. So you will be able to see. Let's see what is factorial. So for you guys, I'll just increase the size. So if you see here, factorial is written as n and with the exclamation mark. So if here it is 5, then 5 until it goes on. Like first it will do -1, -2. So if you see here 5, 4, 3, 2, 1. So we can solve this kind of problem using recursion. So let's see how we can write this problem in Julia to solve like factorial. So let's go through it. First of all, what we'll do, we'll write the function. I'll call it as factorial and I will give it as name n. N is the number which it accepts. So now if our condition would be if n is equal to 0 or n is equal to 1, then we have to return 1. Okay. Else what we can do is that we can return n which is 5. For example, here it is 5, yeah, and n minus 1 itself. So this you can see this is the function n minus 1 factorial. So it has also given the factorial recursion thing. So we can just write fact of okay, factorial of n minus 1. Now what I will do here is that I will end this one and even I will end this code. Now let's run this factorial. I'll call factorial of 5. So you see here I have written the 20. Now let's see what is happening inside this. So what I will do here is that I'll do show n, which will show us the number, and here what I can do is that I'll save this value in result and into factorial of n minus 1 and let me return the result itself. And what I can do before this is that add show result. Now let's see what happens. So if you see here, what we have done, we have printed the n value. So if you see, First, at the time when it is going factorial, it is going inside this function and it is calling for n equal to 5, and then n equal to 4. Here, like it will call here factorial n minus 1, which is 5 minus 1, 4. So this is the function. Here it goes into recursion mode, and here it is 4, here it is 3, 2, 1. Now every time we are getting the result, first we are getting the result as 2, then 6. So if you see here 2 and then 2 into 3, so this comes in reverse order, 1 into 2, but yeah, 2 into 3 and 6, 6 into 4, 24, and 24 into 5, 20. So this is how we are getting the result and we are returning the result. So you can see here, like here factorial is automatically, we don't write multiple loops and all etc to solve this problem. We are just using one function to solve this. Sorry for that. Now let's see another example how we can solve Fibonacci series. So to solve Fibonacci series, it is not needed. In fact, Fibonacci series is not recommended to be written in with the help of factorial, but yeah, we'll show it here. Ideally, the best ideal way is to do with some generic function where it takes the two elements. Now Fibonacci series, if we see, Fibonacci series is something like which returns the addition of two numbers. So if we see here on Wikipedia, we'll search Fibonacci sequence. So if you see here, Fibonacci series is something like where each number is added at once. So like 0 plus 1, 1, 1 plus 1, 2, and then last two, addition of last two digit number 3. Now here the addition of last two digit number is 5. So Fibonacci of 5 is 5. Fibonacci of 6 is 8. So 3 plus 5, 8. And Fibonacci of 7 is 5 plus 8, 13. So hence it continues. Now, so now what we can do here is that let's try to solve this in our code. Now what we can do, I'll just go through the code. Function fib, go, I'll just write fib, and then I'll take the type parameter here is int, and if n equals to 0, we'll return 1. We can also do the same thing which we did here, or n equals to 1, we'll return 1. Else what we can do, return of fib of n minus 1 plus n fib of n minus 2, because we want the return of last two digits, sum of last two digits. So if you go to the fib sequence here, so fib for 8, it is last two, fib of n minus 1 is 5, fib of n minus 2 is 3. Like fib of 5 we have to find and fib of 4 we have to find. Now what we'll do, we'll print here end, and now what I'm going to do is that I'm going to run fib of 7. Let's see, or let's do 5. So if you see here, it is printing 8. So Fibonacci of 5 is 8. Okay, there is one mistake here. So Fibonacci of 0 is 0 always. So guys, my bad. So if n equals to 0, then we'll return 0. And if else if n equals to 1, we'll return 1. So yeah, fib of 5 is 5. Now we are right. And fib of 6 is 8. Fib of 7 is 13. Let's see, fib of 7 is 30. So this is how we can also print the series in sequence, which is another way. So you can see how to print the series in sequence. For now, we'll just print the numbers. So if I have to show here, you can decode this using @show n, so what it is printing, and we can also use the fib result. You can store this value in fib of n minus 1 plus fib of n minus 2. and we will show fib result, and instead of returning this thing we will return fib result. So if you see here, it is trying to do for n equals to 0 fib result is 1, for n equals to 1 fib result is 2. So in this way it is calculating. So for n equals to 3 fib result is 3, for 5. So we'll have to see how we can try to, like, basically it is looping multiple times for each of them and then it is computing. You can check on the, so if you go to the real Python website, so this explains very perfectly the Fibonacci series. Now here if you can see, this is the diagram how it occurs for Fibonacci series 5 and how the whole recursion follows. I recommend go to this website and I'll also paste it in my description so you can learn the Fibonacci series end to end in detail. This is really good explanation of how we can create the Fibonacci series using recursion, or like how we can do it. So please, yeah, go through this website.